Hey guys, so we're exploring different parent functions today, and so I'm gonna walk through with you how to graph parent functions given just what you're given on this handout. Okay, so first I'm gonna do the cubic function, and then I'm gonna do the function next to it, the square root function. All right, so for the cubic function, we have our function f of x equals x cubed. Okay, so you guys actually have a graph already drawn, which is awesome. And then you have that you want to find the domain, range, and then where it's increasing or decreasing. All right, and okay, let's begin. So we want to sketch the graph. Now, guys, the best way to sketch the graphs if you don't know what they already look like is make a table and plot those points. So I'm going to come over here and make a table of our x values and our y values, which is just the same thing, right? F of x, that's just another way to say y. Oops. Oopsies. So this is another way to say y. Okay. All right, so we're going to want to plug in values in for x, and we can choose really anything that we want. We don't have any restrictions here because it's just a number that is being raised to the third power. We can do that to any number, okay? So let's say I usually like to pick numbers around 0. So I'm going to pick -2, -1, 0, 1, 2. That's kind of what I usually start with, and then once I start plugging them into x, I can see, do I need to change these numbers up or are these good, so on and so forth. All right, well, how do I get my y values? All you need to do is substitute in what you chose for x into x of your function, okay? So when I do that here, I'll do that right here. Okay, so if I want to substitute in -2, well, -2 cubed, don't forget we are cubing the entire x value, and that negative is attached to that x value too. So we're cubing -2. Well, -2 times -2 times -2 gives us -8. Negative times a negative times a negative is a negative. So we know we have a point when we plugged in -2 for x, we got -8 for y, okay? Now if we plug in -1, well, -1 multiplied to itself 3 times is -1. So we have the point when we plugged in -1 for x, we got -1 for y. Now 0, if we plug in 0, well, 0 times 0 times 0 is just 0. Now if we plug in 1, 1 cubed is just 1. And now if we plug in 2, 2 cubed is just 8. Okay, so now we have a good list of points, and we can go ahead and put these on our graph. Okay, so I'm just going to make little tick marks. All right, so I'm going to plot my point -2, -8, -1, -1. I recommend you also begin plotting these. So everything I'm doing right now, you should also be doing on your handout. 0, 0, 1, 1, and over 2 up 8. Okay, and now you just want to connect these dots. Okay, so I'm going to connect them as I move left to right. Okay, and I have no more dots to connect. And there's our graph. I should have done that in a different color or something. There you go. All right. So now we want domain range increasing, decreasing. All right, well, for our domain, that would be like asking ourselves, are we restricted for what x values we can have, okay? We can either look at the graph or we can look at our function itself. Well, first off, looking at the graph, it looks like that this arrow here, so remember, domain is left and right values. So we're looking at our line, our red line here, and we're asking ourselves, will this line ever stop moving to the left? I know it looks really steep right now, and it is, but it's going to continue moving to the left, okay, very slowly but surely. Sorry, very quickly. It's going to be moving to the left, okay? Now, if we're moving to the right, same thing. The arrow is going to keep going to the right. It's very steep. It's hard to tell, but it is still moving to the right. Also, look at the function. Are we restricted for what numbers we can plug into our x here? No, we can cube any number we want. So, domain, we can either say all real numbers. You could say from negative infinity to infinity, etc., etc. I'm going to do interval notation. And if you remember from last year from Algebra 2, infinity gets parentheses because it is a concept, not an actual number. So we use parentheses when we're not actually equal to something. And infinity we can't be equal to. Okay, sorry guys, it's really early right now. All right, where am I at? Oh, range. Okay, so now range, we're looking at our y values. Are those going to be restricted? Well, same thing. Look at your lines on the graph. Will this arrow ever stop moving down? No. Will this arrow ever stop going up? No. Also, if we're not restricted in our x values and we can plug in any number we want into x, we're going to get just about any number for y too. So we are not restricted on the range either, so negative infinity to infinity. All right, now increasing. So it's asking when, for what intervals are we increasing? So think as we move left to right, okay? That's how we read our graphs, just like we read. So as I put my pen on this graph and I'm moving to the right, notice I'm not going down at all. At every point, I'm going up, okay? So that tells me that I'm increasing on this entire line here, or this entire curve, and so I am increasing at all times, and I'm never decreasing, okay? Again, because we read graphs as we move left to right, and we're going up. All right, so for increasing, negative infinity to infinity, decreasing, that doesn't exist. Sorry, my cat's got the zoomies. Okay,